This is for chapter 12.6, the first videos. So this section we are doing optimization problem. This is one of the major application problem for business mathematics. This problem involves finding the absolute maximum and minimum that we practiced from the last sections. And as you work through this section, you notice that the statement of the problem does not usually include the function to be optimized. Often it is your responsibility to find the functions and then find the relevant absolute extremer. So we will have to set up those function equation ourselves, and we list a few steps that you can use to try to help you to solve this problem, including step 1, try to find a variable, look at the relationship between them, and put together some mathematical models for the maximize or minimize function. And the second one, we need to take the first derivative to get the critical number or the critical values, and using those process that we practice in chapter 12.5, we need to find the absolute max or minimum between certain interval most of the time, and then we will use the solutions from there to answer the question we have. So those are some of the steps we are going to follow. Let's look at number 10 and 12. So those are kind of matching some of your homework problem. That's why the number looks so random. So the first questions, we have finding two number. The sum is 21 and you want to maximize the product. So the first two is kind of like a basic practice question, not really like application problem, but we want to practice how this works first. So for number 10, we know the sum should be 21 for two numbers, and then we want the product to be maximized. Okay, so which means we have two numbers. So if we let the first number equal to x, this thing is kind of crooked, sorry. If we let the first number equal to x, then the second number, because together they're 21, right? So I can use 21 subtract the first number to get the second number. So the two add together should be 21, right? So when we set the function, we can use the product to form the function. So to set the function, we can use the product to form the function. Okay, so the product for this function, we're gonna say f of x equal to, the first number is x, multiplying the second number is 21 minus x, and we want to find the absolute max. Okay, so this particular function, if we multiply together, because I don't want to take the derivative like that, because otherwise you're going to need to use the product rule. We can multiply them together. That would be 21x minus x squared, right? And if I take the first derivative, then we will have 21 minus 2x, right? Hopefully you guys are pretty good taking the derivative now. To find a critical number, we need to set the function equal to 0, right? Okay, so we got 21 minus 2x equal to 0, so 21 equal to 2x, and divide both sides by 2, basically x equal to 10.5, right? So that's one of the number. And if we use the second derivative to get the absolute max, then we can go ahead and take the second derivative. That's your critical number, right? Second derivative test. Using that, this would be 0, right? Minus 2. So the second derivative is just negative 2. When you have a negative number, it's a sad face, right? So it's going to be concave down. So that's why your critical number is going to be your absolute maximum, right? Okay, so this proof, because the concave down, then you have an absolute maximum for your critical number, and that's my critical number, right? So the first number we conclude is 10.5, and then the second number is going to be 21 minus 10.5, which is also 10.5. So it turned out to make the product to be a maximum. We basically divide that 21 by 2, right? So they say found those two numbers, so you can say the two numbers are 10.5 and 10.5. So they will add together equal to 21, and the product would be maximized. Okay, that's number 10. If you need to pause the video and write that down, please feel free to do it. Let's look at number 12. So let's look at number 12 here. So the second question say we are going to find two numbers. The difference is 21 and the product is a minimum. So if you, this is kind of similar to the last one, so if you want to pause the video and try that on your own, you can, and then you can come back and check your answer. So when you're ready, number 12 say you have two numbers. The difference between them is going to be 21, and you want the product to be minimum. Okay, so we can let the first number equal to x. What do you think the second number would be? The difference is 21, so if you have two numbers and they subtract each other, it will be 21, right? So it will be 21 adding x, because the difference between them is 21, so we need to add it back to the second number. So again, we're going to use the product to set the function. Alright, so if we use the product to set the function, then f of x will be x times 21 plus x. Alright, which means f of x is 21x plus x squared. So that's my function, and then we need to find the critical number. We're going to set f of x, f prime of x equal to 0 to find critical number, right? So we need to find f prime of x first. F prime of x is 21 plus 2x. If we set that equal to 0, then we have 21 plus 2x equal to 0, and we can subtract 21 to the other side, I guess. So 2x equal to negative 21 divided by 2. Okay, then it's going to be x equal to negative 10.5. Okay, that's a negative number. Okay, that's weird. But that's your critical number, right? And then we can use the second derivative test. And see if it's concave up or concave down. So f double prime of x, using that, take the second derivative, we get 0 plus 2, right? So f double prime of x is a positive number. When you have a positive number, positive people smile, so the graph look like that. Is concave up. Okay. And then you will have a minimum value, minimum number at the critical point, right? Okay, so we will you can plug it in. F double prime of negative 10.5 is still going to be true, so the first number is going to be negative 10.5, my critical number, and then the second number would be 21 plus negative 10.5, so it's 10.5. So that's why when they multiply together, that would be a minimum, right? Okay, so the answer would be, the two numbers are negative 10.5 and positive 10.5. So when the difference between them is 21, and then when they multiply together, you form a minimum number. Alright, so that's number 12. When you can pause the videos when you're ready. We're going to look at number 18 together. So number 18. Found the dimension of a rectangular with a parameter of 76 and has a maximum area. So some of this question is building you to be able to solve those questions. Maybe packagings, like you need to find out the dimension of a box for candies or other stuff, or like canned food, the dimension of the can, etc. So it does have some application you can use for these skills. Let's look at number 18. The dimension of a rectangle with a parameter, meaning you add up all four sides, is 76 feet, and you want to maximize the area. So number 18, let's write down what we know. So we know we have a rectangle with the length and the width. We don't know either one of them, so I can say one is x, you can say one is y, but it would be better if we just have one variable. So instead of y, I can say try to find what that is. So let's do x and y first. Okay, so how do we find parameter? So we're gonna let, cannot spell, sorry. really tired lately, sorry about that. So we're gonna let x equal to the length of the rectangle, y equal to the width. Okay, so when you have the parameter and they say equal to 76, right? How do you find the parameter? You add the length and the width and the length and the width, right? So x plus y equal to 76. Do you agree? So basically you have 2x plus 2y equal to 76. It looks like everybody can be divided by 2, right? So I can divide everything by 2. That would give me x plus y equal to 38. And if I solve for y, then we got y equal to 38 subtracting x, right? We subtract x both sides. Are we okay? So instead of y here, we can replace y equal to 38 minus x. So this way, we only have one variable, x. So it will make the question a little bit easier. So what we want to do is we want to maximize the area. Agree? So do we know how to find the area for rectangle? So finding the area for the rectangle is going to be length times width. So the area is going to be, the length is x, the width is 38 minus x, right? So we can say this is my function. We have x times 38 minus x, and we need to maximize this. So we want to find the critical number by finding the first derivative and set f pi of x equal to 0, right? Sorry. Okay, so this one, f of x, is going to be 38x minus x squared. So that's my function. So if I do f prime of x, I have 38 minus 2x, and then I need to set that equal to 0. So 38 minus 2x equal to 0, and move the 2x to the other side. 38 equal to 2x, and divide both sides by 2. So x equal to 19. So that's my critical number, right? And then we want to use the second derivative to make sure that it's the absolute max or relative max. So second derivative test, we're going to do f double prime of x. So this turn into 0 minus 2. So f double prime of x equal to negative 2, which means that I have a negative number. So negative people is set. So concave down. With that, my critical number is also my maximum. Alright, so which means that one of the length or the width is 19, right? So x equal to 19, the length, and then the width is going to be y equal to 38 minus 19, which is also 19. So in general, a lot of time square is going to be what you need, right? So the dimension we spelled dimension of the rectangle is 19 feet by 19 feet. So what is the area? The area would be 19 times 19 equal to 361 feet square. Is that what they ask? So dimension of the rectangle and the maximum area. So that's the max area, and then this is the dimension, 19 by 19. Alright, hope that makes sense. If you have questions, please email me.